Good morning to all. Today we are here to discuss about the properties of solution. In this class, we will discuss more about solutions, types of solutions, properties of solutions and stabilizers. All the solutions are mixtures. A solution is a homogeneous mixture of one or more solutes dissolved in a solvent. Here are some examples of solution we have used in our daily life, that is sugar water, salt water, natural gases, etc. Then what do you mean by a true solution? A true solution is the one that comprises all the particles in a correct composition and has been properly dissolved in. As a result of this type of solution is known as a real solution. For example, sugar solution is prepared by dissolving sugar in water, which is a clear solution. And next, colloidal solution. The mixture in which one substance of dispersed insoluble particles is suspended throughout the other substance is known as colloidal solution or colloids. Milk is an example of colloidal solution. And next is suspension. A suspension solution is a heterogeneous mixture of two or more substances where the solute particle do not dissolve and remain suspended throughout the solution. Muddy water is an example for suspension. Let us observe a video and write the observation results in your science diary. We are going to discuss more about the properties of solutions. In the first case, that is in solution, the path of the beam light is not visible, but in suspension and colloids, the light beam's path is visible. When we filter these solutions using a filter paper, components can be separated by filtration. It occurs in suspension, and in solution and colloids we cannot separate the components. When we kept these three solutions undisturbed for some times, we can see that the particles are settled down in suspension, and in solution and colloids they do not settle down. Thus, we can move to the inferences that the size of the solute particles present in a solution is so small that it cannot be seen with naked eyes. Since these particles are very minute, they cannot scatter a beam of light. Hence, the path of the light beam is not visible. In the case of colloids, the solute particle size is comparatively bigger. Hence, they scatter a beam of light and thus making the path of beam visible. Particles of suspension are big enough to see with the naked eyes. Thus the light falling on them is reflected almost completely. Then they gradually settle down under the influence of gravity. Let us observe another video and write your observation results in your science diary. Prepare a solution by adding 2 grams of sodium thiosulfate in a beaker containing 50 ml of water. Arrange the beaker in the path of the beam of light as shown in this video and add a few drops of dilute hydrochloric acid into it and stir the solution and observe for a while. We can see that the sulfur gets precipitated when sodium thiosulfate reacts with dilute hydrochloric acid. Before the chemical reaction, the mixture existed as a solution. Within few seconds, as more and more sulfur particles forms and they get aggregated together, the particle size thus gets bigger and forms a colloid, making the path of the light beam visible. Further, more and more sulfur particles get separated and the size of the particles keep on increasing. Thus, the mixture becomes a suspension. Here we can see that the light beam is reflecting. Thus the solution becomes a suspension. Here, the scattering of light by colloid particles is known as Tyndall effect. Next, we move to stabilizers. Most of the juices that we drink are liquid in colloidal form. Such juices and liquids are available in the market. They do not settle down even after a prolonged storage. These are some examples for juices that we have drink, that is Coca-Cola, Sprint, etc. Some chemical substances used as stabilizers in soft drinks to prevent the particles from getting settled are called stabilizers. Brominated vegetable oil, sucrose acetate isobutyrate, glyceryl ester of rosin are the examples for stabilizers. Here, the table of content presents chemical substances and to which it is added and it is uses. First one is tartrazine, which is added in food material as a coloring agent, which gives yellow color to the food material. And the next one is erythrocin, which is added in food material as a coloring agent and which gives red color to the food material. And third one is vanillin, which is used as a taste enhancers in food material. And next is phosphoric acid, which is used in soft drink to give a sour taste. and the final one is allyl hexanate, which is used in food materials for fragrance, which gives the fragrance of a pineapple. Hope you understand all the concepts in this video, that is properties of solutions, solutions and types of solution, and finally the stabilizers. Thank you.